Good morning, children. Stay safely at home. So I am starting the next topic of the rotational motion chapter. Next one is theorem of parallel axis for moment of inertia. Now what the theorem states that moment of inertia of a body about any axis is equal to its moment of inertia about a parallel axis through its center of mass plus the product of the mass of the body and the square of the perpendicular distance between the two axes. So what is the meaning? Just try to understand it. Suppose there is a body, you have to find out moment of inertia of the body about this axis. Alright, so you have to find out I, moment of inertia about this axis. Then how you can find out? Moment of inertia I will be equal to, suppose this is the center of mass, this is the center of mass of the body, is equal to moment of inertia of the body parallel about an axis parallel to it. You see how I have drawn another axis parallel to the previous one and passing through center of mass. So this is ICM plus product of entire mass of the body and the perpendicular distance. Let the perpendicular distance between the two axes be A. Product of mass and square of the perpendicular distance between the two parallel axes. So IC is equal to ICM plus MA square. Now here there is a suggestion, those who are unable to write down the statement, theorem of parallel axis in statement, at least draw the diagram and write down the relation. Then also you will get mark. Okay, unable to write down these statements because sometimes some of you, those who are very much interested in studies, they are unable to write the statement. In that case, what you have to do? Draw the diagram showing everything properly in the diagram and then write down the equivalent mathematical expression for the theorem of parallel axis. Okay. Now, we have to prove this theorem of parallel axis. So, for that, suppose I have taken one particle. Suppose it is the, I can say this is the ith particle. And let us consider the mass of the particle be Mi. Is that clear? And the distance of the particle from the ICM is Ri. Alright? Then you see what is this distance is Ri. Don't have to draw this. This distance is Ri. So you see one can write according to our concept of moment of inertia. Moment of inertia is sigma mi into Ri square. But in this case, what is the distance of the particle chosen from the axis under consideration? Ri plus a. So you can write it as Ri plus a whole square. Is that clear? Now you expand it. This is summation is over I. Now you expand it, a plus b whole square. You can write it as sigma mi Ri square. Then it will be 2 Ri a. So you can write 2 sigma mi Ri into a plus sigma mi a square. Is that clear? Now sigma mi Ri is 0. Alright. So, and look at this sigma mi Ri square. Sigma mi Ri square is nothing but moment of inertia of the body about the axis passing through center of mass, because Ri is the distance of the particle from this axis passing through center of mass. So sigma mi Ri square is nothing but ICM, moment of inertia about an axis passing through the center of mass. Now the second term is 0. Why the second term is 0? Because sigma mi Ri is 0. Alright, sigma mi Ri is 0 because if you consider any rigid body, then the entire mass is distributed uniformly about the center of mass. Is that clear? We assume that. That's why sigma mi Ri is always 0. Then the next term, you see sigma a square is constant, isn't it? So you can take a square outside the summation. So a square sigma mi. Now sigma mi is what? m1 plus m2 plus m3. This is the way you will take the mass of all the particles constituting the rigid body. So sigma mi is nothing but the total mass of the rigid body. So you see what you are getting? ICM plus sigma mi is equal to m, big M, the total mass of the body, ma square. So it is proved that I is equal to ICM plus ma square. Very important topic for your exam. So everybody should learn this derivation and practice it repeatedly. Now next is theorem of perpendicular axis. So theorem of perpendicular axis states that the moment of inertia of a uniform plane lamina. So suppose you have taken a uniform plane lamina about an axis perpendicular to its plane. So you have taken an axis perpendicular to its plane. It will be equal to sum of its moment of inertia about any two mutually perpendicular axes on the plane of the lamina. So you see, you have taken two axes, this x and y, these two are on the plane of the lamina, alright, and intersecting the first axis. So if you consider x and y are the two mutually perpendicular axes on the plane of the lamina and z be the axis perpendicular to the plane of the lamina, then according to theorem of perpendicular axis, Iz is equal to Ix plus Iy. Alright, moment of inertia about axis z is equal to sum of moment of inertia about x and y. Is that clear? So again I am saying that those who are unable to write down the statement, they learn the diagram and write down the equivalent mathematical expression. Then also at least you will get marks. Now how you can prove this? Again we have taken one ith particle and which is at a distance Ri from the z-axis. Is that clear? Now actually x, y, z, they are mutually perpendicular to each other. Now it is a three-dimensional diagram, but it is not possible to draw x, y, z perpendicular. So x and y, they are inclined this way. But remember that x and y, they are perpendicular to each other. So if you draw a line parallel to x-axis and draw a line parallel to y-axis, is that clear? Then you see the distance of the particle from x-axis, that is yi, and the distance of the particle, means you can consider that this is yi and this is xi. Is that clear? Means this length is xi and this length is yi. Is that clear to everyone? So you see, Iz, you can write it as from the diagram sigma mi Ri square. Okay, because Ri is the distance of the particle from z-axis. Clear? Now, you see, Ri square is nothing but xi square plus yi square, because x and y axis, they are like this. Actually x and y, they are perpendicular to each other. Alright, so you see, if you consider this is r, then r will be how much? Y square plus x square. This diagram you don't have to draw. So you see, Ri square you can write xi square plus yi square. So if you separate the terms, you are getting mi xi square plus sigma mi yi square. Now, what is sigma mi xi square? Iy. Because xi is the distance of the particle from y-axis. So, mi xi square is iy and mi yi square is equal to ixy, because yi is the distance of the particle from x-axis. So sigma mi yi square is ix. So you see what you have got, Iz is equal to Iy plus Ix. Ix plus Iy and Iy plus Ix is same. So this is the way you can prove the theorem of perpendicular axis. So once again I am just reminding you that theorem of perpendicular and parallel axis both are very important along with the derivation for your exam. So please do learn and practice it. Now we have to know the moment of inertia of different object about an axis passing through its center of mass, that will be given, and applying the perpendicular axis and parallel axis theorem, we have to find out the moment of inertia of the same object about different axes. Okay, so the first case is moment of inertia of a thin rod. So suppose you are having a thin rod, then you know the center of mass is situated at the midpoint, isn't it? So if you consider an axis passing through the center of mass and perpendicular to its length, this is the length, alright, this is the length, and let us consider m be the total mass of the rod. Clear? Then this is center of mass, this is center of mass. So what will be the moment of inertia of the rod about an axis passing through center of mass and perpendicular to the length? Okay, it is given by ml square divided by 12. The derivation, actually that calculus part is omitted from your portion, so the derivation is not there. That's why you have to just learn and remember the relation. Okay, that moment of inertia of a rod, thin rod, about an axis passing through center of mass perpendicular to its length is given by ml square by 12. Now, the second case is that you have to, so this is known to you. Now you have to find out what is the moment of inertia about this axis. About this axis. You see, passing through one end of the rod and parallel and perpendicular to the length of the rod. Then you see, one can apply the concept of theorem of parallel axis, because this is ICM, isn't it? And you see what is the distance between these two axes now? This is I. It will be L by 2. L is the total distance. So what will be this distance? L by 2. So you see, you can write according to parallel axis theorem, I is equal to ICM plus M into square of the distance between the two parallel, MA square. Now what is the value of A here? L by 2, so it will be L by 2 whole square. Now you substitute ICM, it is ML square by 12, and then it will become ML square divided by 4. So on simplification, how much it will come? It will come ML square by 3, because you see it will be 12, then it will be 1 and it will be 3, so 3 plus 1 4, 4 divided by 12 is 3, so is equal to ml square by 3. Clear? So you can clear? So ICM is ml square by 2, which is direct formula you have to remember, but applying the parallel axis theorem, what you are getting? Moment of inertia about an axis passing through one end and perpendicular to the length is given by ml square divided by 3. Okay, you should practice all these relations and this derivation applying the parallel axis theorem. Now next topic is moment of inertia of a rectangular plane lamina. So you have taken a rectangular plane lamina, then you have to, this is also derivation by the method of calculus, we can derive it. It was there earlier in your portion, this year it is removed. So moment of inertia of this lamina about an axis passing through center of mass, this is the center of mass, perpendicular to the lamina. You see here, when I have drawn this axis, I have not drawn it continuous. Here there is a gap. This gap indicates that in 10th standard also I taught you the same thing, that whenever a line drawn this way putting a gap, it means that the line is perpendicular to the plane. Means if this is the plane of the lamina, the axis is like this, it is perpendicular to the plane. Okay, in that case ICM is how much? M is the entire mass of the lamina. into L square. L is the length of the lamina, plus B square. B is the width of the or breadth of the lamina, divided by 12. So you see, it is easy to remember. For a rod, thin rod, B is negligible. In that case, ICM was ml square by 12. And when it is a plain lamina, breadth is not negligible. In that case, it is m into L square plus B square within bracket divided by 12. So this is the basic information given. Then we can find out the moment of inertia about other axes using the perpendicular as well as parallel axis theorem. Now next is moment of inertia of a ring about an axis passing through the center of mass. You know, for a ring, at the center, although there is no material, but center of mass lie at the geometric center. So passing through the center of mass and perpendicular to its plane. So you see, once again I have drawn the axis. Here discontinuous means this axis is perpendicular to the plane. It is given by ICM is equal to m into r square, where m is the total mass of the ring and r is the radius of the ring. So it is asked that about the diameter, moment of inertia about one of the diameter. How you can do? You can use the perpendicular axis theorem. Just you see, if you consider the two diameter, they are perpendicular to each other, isn't it? And if I consider the ICM is like this. So you see, if this is x, this is y, this is z. So you can write about the diameter. How you can find out? That according to perpendicular axis theorem, you can write ID means moment of inertia about one of the diameter plus moment of inertia about the other diameter is equal to ICM. Is that clear? Now, what is the value of ICM? ICM is equal to mr square. ICM is mr square, and here ID plus ID means 2ID. So what is the moment of inertia of the ring about one of the diameter? According to perpendicular axis theorem, it is given by mr square. Mr square divided by 2. Now next is moment of inertia of a disc. Oh, I forgot to change the numbers. First it will be 4, no? First it was rod, then rectangular lamina, second, third will be the ring. Please change the numbers. I forgot to change the numbers here. And fourth one is the disc. For a disc, here also materials are there. So here also you have taken the axis passing through the center of mass and perpendicular to the plane. In that case, moment of inertia is given by mr square by 2. Alright, so if you know this, then you can find out what will be. So you tell me what will be about the diameter? What will be the moment of inertia about one diameter? About the diameter. Again, you can do this, that about the diameter means according to perpendicular axis theorem, it will be ICM. So ID will be ICM by 2, means it will become mr square by 4. Okay, this is according to perpendicular axis theorem. Alright, so we have learnt about the rod, rectangular lamina, then ring, then disc, then coming. So if you consider moment of inertia of a solid cylinder about an axis passing through the center of mass and perpendicular to the length, where r be the radius of the cylinder. It is given by m into L square by 12 r square by 4. In the book it is mistake, it is written h, it will be r. Okay, r is the radius of the cylinder. Okay, so this is, remember, this is the moment of inertia of a solid cylinder. Now next is moment of inertia of a hollow cylinder. And you know that hollow cylinder having two radius, the external radius big R and the internal radius small r. Now in this case you can find out the moment of inertia about its own axis. This is its own axis. So it is given by m by 2 r square plus small r square. You see actually how it is coming. When you are trying to find out about its own axis, then you see nothing but there are two discs. isn't it? One of radius bigger, another is radius smaller. So it is given by m by 2 r square plus m by 2 small r square. Is that clear? So this is about an axis, about its own geometrical axis. Now if you consider the moment of inertia of a hollow cylinder about an axis passing through the center of mass and perpendicular to its length. This is the length. Alright, this is the length of the cylinder. It is given by, this is the axis y dash, I have denoted. So you can write I by y dash, or you can write ICM also. It is m into L square by 12 plus r square plus big R square plus small r square divided by 4. So many new formulae you are learning. So until and unless you write it, practice it several times, you will not be able to remember the formulae. So I request everyone, please learn and practice and remember all the formulae for moment of inertia, especially moment of inertia about an axis passing through the center of mass, that is ICM. Next is coming moment of inertia of a solid sphere about its diameter. Remember that diameter is also the axis passing through the center of mass, because for a solid sphere, geometric center is the center of mass. It is given by 2 mr square by 5. You can write ICM also. I have written D here, but in the diagram I have written ID is equal to ICM. Then you have to find out what is the moment of inertia about a tangent. So you see, when you are drawing the tangent, how it is looking. It is becoming parallel to ICM. So which theorem you can use? According to parallel axis theorem. What you can write? That IT will be ICM plus m into, now you see what is the distance. Distance is nothing but the radius of the sphere. So ICM into m into r square. Now ICM is how much? 2 by 5 mr square plus mr square. So it is coming 7 by 5 mr square. So this is the moment of inertia of the sphere about the tangent. So in this case, you see, you have applied parallel axis theorem. Now next one is moment of inertia of a hollow sphere. So you see, inside is hollow. So it has external radius bigger and internal radius smaller. In that case, what will be moment of inertia about the diameter? 2m by 5 into r to bigger to the power 5 minus smaller to the power 5 divided by big R cube minus smaller cube. Then next one is moment of inertia of a spherical shell. Alright, then about its diameter, it will be given by, remember that here also that it is moment of inertia about the diameter, means it is about the center of mass. It is given by 2 by 3 mr square, where m is the mass of the spherical shell and r is the radius of the spherical shell. So today in this lecture, so many unknown and new formulae you have learned. So please girls, once again I am requesting you, learn it, practice it by writing it repeatedly. Alright, thank you girls, that's all for today.